Hi everyone, and a very warm welcome to this webinar session from Epotronic. In today's session, we'll be presenting a basic introduction into UAV and LiDAR. I'm happy to be joined by Tobias Vensler, who is the CEO of Epotronic.
Hi everyone.
And I'm also joined by Alex Lynott, who is one of the surveying engineers at Epotronic as well.
Hi guys.
And also with us is one of the world's leading LiDAR manufacturers. And I'm very pleased to say that we've got one of their most experienced customer success managers joining us today from GreenValley's HQ in Berkeley, California, Liam Meyer.
Hello, everyone.
Contact information for all of us will be displayed throughout the webinar and placed in the description too. And at the very end, we will also have an additional slide with some details on how to contact us. So what to expect from this? This is the first webinar of a series. We will present some use cases at the end of the session. And if you drop us a comment or send us an email at info@epotronic.com to let us know which use cases and equipment you find most interesting. So we could go into more depth on that on the next webinar. We can also tailor them to suit your needs, especially when it comes to GVI hardware and software suites too. But right now, what can you expect from this webinar? So we can give a professional overview of LiDAR and its capabilities with a UAV platform. So before showing you the topic overview of this webinar, let's have a short and quick look into what LiDAR actually is and what it does. So, what is LiDAR? Simply put, LiDAR is light detection and ranging. And what it does is it shoots pulses of light towards an object or the ground at thousands of times a second. The light then bounces off the object and is received back by the LiDAR sensor. It then measures the time the whole pulse and return sequence takes, multiplies it by the speed of light, and then divides it by a total of 2 to create an accurate distance. LiDAR scanner also includes critical information from an inertial measurement unit, or IMU for short, where it records pitch, roll, and yaw parameters, while a GNSS unit records the positioning of the sensor. All of this data is then integrated with the LiDAR results to create some highly accurate data measurements. Naturally, there is a lot more to it than that, but that should bring you up to the basics on how a LiDAR system operates. So now we're up to speed on the basics of LiDAR. Let's have a look at the contents of this webinar and what we will be discussing together. So next up, I will pass over to my CEO, Tobias, who will introduce Epotronic, what we do and how we do it. Following that, he will then hand the reins over to Liam to introduce us to GreenValley International, or GVI for short. Then Liam, Alex, Tobias, and myself will discuss some LiDAR topics in more depth. This includes things like some comparisons over other hardware solutions and some example case studies for LiDAR topics. Then we'll finally cap it all off with a sneak peek as to what we will be covering in the next webinars. So without further ado, allow me to hand over to my CEO, Tobias, to introduce Epotronic. Tobias.
Thanks, James. So to give you an overview about Epotronic, who's that company? We are based in Düsseldorf, Germany. At the moment, we are around 6 people. 2 out of these people are surveying engineers. And we have Alex here today with us, as James already mentioned, very good surveying engineer with a lot of theoretical background, and we'll get to know a bit of that one later. Then we also have Mohammed, who has a lot of application surveying experience all over Europe, also some Eastern countries. And therefore, we are a specialized distributor for unmanned aerial surveying and inspection products. We have an access to a lot of different kind of products, complementing all of them together to provide a full suite of unmanned aerial surveying setup for surveyors, companies, construction companies, power line companies, service providers who are looking to extend their drone portfolio, just have dipped into this topic. We are going all into these ones later, and there might also be some other platforms that we will have joining our portfolio in the near future, not just flying robots, but maybe also some ground robots. Let us know what you think about this idea, and maybe you have already touched that topic. And I would just like to say that we are not providing only the products, we are also doing the consultancy services in order to make sure that the products you're purchasing are perfectly fitting to your workflow. We are providing workflow guidelines then later for self-studying. And if you say you would like to have a direct introduction, there's the option that we do the on-site training with you together or an online training, as well as some pilot testing cases to see that the project that you're having can be fulfilled with the equipment that we would sell to you. But also, of course, there would be the option to have them leased by us. And in this session, as James already said, we are one of the specialized dealers of GreenValley International products. We would like to give you a bit of an overview. So first of all, I would like to hand over to Liam Meyer to let us know a bit about GreenValley, the system integrator.
Thank you, Tobias, and thank you, James, for that introduction to GreenValley International, or GVI, and myself. Again, I am on the customer success team here at GreenValley International, and what we provide are hardware, software, and service-based solutions for 3D mapping and surveying. Epotronic is part of our global partner network. It extends all over the world. We have exposure in over 60 countries at present. And one of the great things about Epotronic is their depth of knowledge in UAV systems and operations. And this is why they're one of our key partners for the LiDAR series. So before I get into our actual products that are included in the LiDAR series, as well as other ones in our catalog, I just want to let you know a little bit about the history of GreenValley International. We actually were founded back in 2012 right here in Berkeley, California. So actually it was founded by Michael Guo, who was at the time was working on some software solutions that he had developed for extracting out individual tree metrics from forest LiDAR data. So it was this kind of out of this necessity to have software and algorithms that could process forest LiDAR data that was available at the time, that some of these initial tools that you see in our portfolio were developed. And then it led to the actual integration of laser scanners and IMUs and GNSS technologies to develop mobile mapping systems, UAV LiDAR systems, and then SLAM-based systems as well, which is a different category that relates to our LiDAR backpack power line, our LiDAR backpack series of products. The LiDAR series is really where Epotronic is putting a good effort in here and helping us get the name of GreenValley and get our products out there to the market. But in the LiDAR series, we have a couple of different systems. They run a range of different capabilities depending on what the LiDAR sensor make and model is that's integrated. We have something that we're calling like our small aerial systems. And the newest one of these is going to be the LiDAR V70. So this features the Livox Avia sensor. It weighs just over 1 kilogram, so it can provide pretty much the longest data collection times because it can stay aloft for so long because of its low weight of any of our systems at the moment. It's also adapted for easy integration into the DJI Matrice series through the Skyport. But it's also flexible enough to go onto non-DJI drone, pull power from an external source, and we have all the hardware necessary to do that as well. We also have the service capabilities to work with you if you need custom calibration file developed for the way that you integrate something like the LiDAR V into your drone so that you can then process that data using our LiGeo reference software. And you can also choose the option of adding a camera on this. And this is actually something that's quite popular because you can use that pose data collected from the LiDAR V to actually geotag your photos and then push it through a photogrammetric workflow as well. So it can be done in our LiMapper software. The other LiDAR systems that can go on, let's say the M300, because of the new Skyport, would be our LiDAR 50N. This features a Velodyne sensor, so the ability to scan 360 degrees. And also we have a LiDAR S220. This is actually a heavier unit coming in at about 4.5, 4.2 kilos. And this is going to only really be able to be mounted to something like the M600 at this point. But the advantage really of the LiDAR 50 and the 220 over something like the LiDAR V, the LiVox sensor, is this 360-degree field of view for scanning. That's a big advantage. Each system really has its own, so we encourage you to reach out to Epotronic so they can really walk you through points of comparison on the technical specifications of all these devices. Lastly, I just want to, before I hand it back over here, is just let you know a little bit more about some of the software solutions that we have for industry-specific applications. So one is called LiPowerline. This is really geared at vegetation managers who are maintaining assets, especially transmission, high voltage transmission assets, and making sure those corridors are free of objects that could cause a clearance zone violation to occur, or worst case scenario, actually presents a hazard to the system. So that is something called LiPowerline. Again, we have LiDAR 360, and this has modules in it for the terrestrial module for a topographic surveyor, make classic elevation products, and then we have our forestry modules, just to go back all the way to where we started. And these have grown quite a bit. There's nice user interfaces with them now, and they still accomplish the original goal of some of the software algorithm development of making the extraction of information from point clouds easier, and then delivering them in a form that is most useful to those who would consume that sort of data. So that's really all I have about GreenValley. It's nice to be here today, and look forward to the discussion that will take place in this webinar.
Amazing. Thanks a lot, Liam. Quite an impressive introduction of GreenValley and these kind of products. So what we want to do today now further is to give you the overview of LiDAR, what it's basically capable of, how it positions to different kind of sensors, how it compares to the photogrammetry. So what you mentioned, there's so many different kind of LiDARs, also types of LiDARs. Then they are added by an IMU, by the GNSS sensor, and finally we are getting this point cloud of millions of points, each with a coordinate attribute. The very important factor to distinguish between photogrammetry here, that we are having the Z coordinate already measured, so to say, on the fly, and therefore we have an incredibly efficient type of sensor, because for the post-processing that requires just a bit of processing power, or comparably fewer processing power. And then of course, as you mentioned, there's different types. You can say it's a multi-purpose sensor, so terrestrial, on a robot, or on a vehicle, on a backpack, these kind of things, and on the drone. And then there's quite a few things why a LiDAR sensor also adds an additional value. It's something that can capture delicate structures way better because it reflects from this target. Therefore, you know that this is a real point. There's some, of course, maybe particles in the air that could reflect, but therefore we have the software which then takes out all these kind of noises, which is quite good to use. And also when we want to do surface modeling, where a lot of vegetation covers the surface, or we have structures, then the LiDAR would be the go-to solution. And then also we can extend our operational use with the LiDAR, because the LiDAR also works in dawn or even nighttime. Maybe in the future that could be an interesting thing. Also for snow or water, the LiDAR could be a tool to use for. So let's see how the LiDAR positions to other sensors. There is the total stations. We have GNSS rovers, the LiDAR and photogrammetry. That's the main solutions that we're going to list here. And we can show you the overview of the points captured in time. That's immense for photogrammetry, also very huge point for LiDAR, and then it decreases heavily. Alex, maybe you want to tell us a bit about that from your experience, or
yeah, sure. So with total stations and GNSS rover, it's much more limited how many points you can get. It's more like getting a point every minute or every couple of minutes. And that's just tiny compared to what can be achieved with photogrammetry and LiDAR, which is hundreds of thousands per second. And not all of those points would be necessary, but still it's a huge advantage. And then looking at processing time, so this is the processing time to get a exportable product. You can see for photogrammetry, it's got quite a long processing time, so kind of similar to total stations, which also requires a lot of post-processing, the CAD drawing and so on. And that's similar with the GNSS rover, so the points themselves will need to be edited. With LiDAR, you get the point cloud straight away, so it's very quick to get your exportable product. And when looking at accuracy, again, so photogrammetry, it's actually quite good, comparable to traditional methods, or almost comparable, especially with the new RTK drones. And with LiDAR, it's a little bit less, just because of the drone platform. With terrestrial LiDAR, it's a bit higher because it doesn't have to be combined with GNSS and IMU. So looking at the limitations, again, for photogrammetry, because it has to, the point cloud has to be processed from the raw images, it takes a long time. So this means the frequency of surveys is a lot lower. With LiDAR, the main disadvantage would be the setup cost. We'll look at this later, how this is actually not so bad over the long term, but to start with, it's a disadvantage. And with the traditional techniques, the main disadvantage would be their inefficiency, which is significantly lower than with photogrammetry and LiDAR.
So these types of sensors we can mount on platforms. So there's also an overview that we wanted to provide you. What are the kind of platforms? The types to use. We have handheld devices, the GNSS rovers, the total stations, also handheld LiDAR stations. Then we have ground vehicles, unmanned aircraft, multi-copter, fixed wing, manned aircraft, as well as satellites. And here it's a bit similar to the points per time that can be captured. We have made the same listing. Of course, with satellites, you can capture a vast area. The accuracy, however, is a bit limited due to the military. And the deployability here, you would need months or years to shoot out a satellite. Maybe it could have been done in weeks with a lot of money. However, I need to say that, of course, you can get the data from a satellite from online services immediately. Yeah, but that's the question, if you want to have that, if the accuracy is enough, and also if it provides the data set that you require for the specific time. Therefore, there's manned aircraft, and manned aircraft is still quite an expensive solution to provide to do surveyings. Therefore, unmanned aircraft is a bit emerging in this area, and we'll probably see more and more unmanned aircraft in the future when regulations allow to, and this technology develops further. Ground vehicles, that's also one of the things where we see LiDARs being attached to cars, or here to ground robots. And the comparison is a bit similar to the sensors itself. So deployability basically goes from top to down. So the handheld device, of course, can be deployed in seconds or even minutes. Whereas for a drone, maybe you will require some regulatory approvals. So this can go from, in a very efficient setup, it can go from even minutes, just switching on the drones, DJI drones. When you're very familiar with the setup, they are ready to fly literally in minutes. And but if it's a very complex situation, of course, it can also take a bit more, taking all these regulatory approvals into account. The accuracy of a drone is usually a bit less than on a ground vehicle, but it's getting way, way better. The technology is getting more efficient. So the performance to the cost-expensive ratio, that's really taken off. And that's one of the main things. Alex going to show you that with the development of LiDAR in a few minutes. First of all, he would like to get you a bit of a background knowledge, what we're actually talking here about accuracy, and maybe also the relative accuracy and the absolute accuracy. And then we have also precision. So I think that's a topic quite complex and might be confusing. So I hope that he can get a bit more light to that for you.
Thanks, Tobias. Yeah, it is a complex topic, so I'll try and make it simple here. So precision and accuracy, they're two things that are heard quite a lot in the surveying and mapping industry. So first, some definitions. So precision, it's how close repeated measured values are to each other. So you can visualize that in the image shown here. So the targets on the left, they show measurements that are not precise. So the distance between each measured value is quite large, whereas on the right, each measurement is quite close to each other, so that's precise, but it doesn't matter where in the target it is. And the target, I should say, the center of the target represents the true value. So when we're talking about accuracy, it's how close the measured value is to the true value. So the closer to the center of the target, the more accurate. So the two images at the top are the accurate ones. So even if all of the measurements are not right in the middle, it's okay because the average still meets the middle. And this true value, the only way you can know what the true value is to actually measure it, which introduces error. So you just have to do that with a very accurate and precise tool. So both precision and accuracy are important, and it's an important thing to note in your measurements and data. So how do we measure precision and accuracy with UAV LiDAR data? Well, with precision, if you've got a flat surface in the point cloud, such as a road or a flat rooftop, you can make a profile and then you can look at the buffer just to look at the vertical spread of the points. Then you can simply measure the distance between the top and the bottom, and that will give you a value for precision. For looking at accuracy, the only thing you can really measure is in the vertical axis. So what you do is, if you go in the field and get some ground control points, such as with GNSS RTK, and then import that into the point cloud, then you can compare the elevation from these two points, which are classified as ground points, and just look at the offset there. And actually in the GreenValley software, you can then apply a correction to then improve the accuracy. So generally with the LiDAR V70, you can get a vertical accuracy of plus or minus 5 centimeters and a precision of plus or minus 5 centimeters. And from our tests, we saw a point density of around 150 points per square meter.
Yeah, and this of course depends on the sensor type being used. So if you're taking the Regal setup, the 250 from GreenValley, for example, then it could also be 3 centimeters RMSE on the Z-axis.
So moving on, a question which might be quite common is, what are the advantages of UAV LiDAR compared to photogrammetry, especially considering the setup cost? So one of the big advantages is the processing time. So with LiDAR, processing takes about 20 minutes, 10 minutes even for a small survey area. And that's because the point cloud is captured directly. With photogrammetry, it has to be generated from the images. So that could take hours, days potentially. And that reduces the amount of surveys that can be done if you're limited on the number of processing computers you have. Another big advantage is the conditions that LiDAR can be used in. So it can be used in low light, including at night time. It's not at all affected by that, whereas photogrammetry, that's limited to good visibility and light, and photogrammetry as well is prone to shadows and reflections. Another big thing is when you're surveying vegetation, because LiDAR can penetrate through the canopy, so it can get points generated for the canopy in the middle of the forest structure, also the terrain, so you can reconstruct the terrain below the forest or whatever vegetation is there. With photogrammetry, it can only reconstruct the top of the canopy, and it would fail to reconstruct the terrain below. Finally, another main advantage here is that LiDAR can capture much finer detail than photogrammetry. So especially for complex objects like buildings vehicles, machinery. It does a much better job of getting all of the fine detail there. So why has this technology just recently become available? LiDAR's been around for a long time, so why is it only now? It is a rapidly developing technology, LiDAR. So traditionally, it was restricted to terrestrial LiDAR scanning, so set up on tripods and also on manned aircraft. So these are generally quite bulky equipment, and from these platforms, there's reductions in efficiency and cost compared to what is available now. So the reason it's now become available is because of the development in the LiDAR and IMU and GNSS units. So they're becoming more powerful, lighter weight, and more affordable. So before it would have been physically impossible as well as infeasible to attach it to a drone, but now that's very affordable, especially when you're looking at the improvements it makes in efficiency. You can survey an area in minutes, which before would take hours with terrestrial laser scanning, and also looking at the cost. So with a manned aircraft, it was huge compared to what the cost of drones is now. So now I'll talk a little bit about use cases. So there's a lot of use cases with UAV LiDAR. We've listed just the main ones. This list isn't completely comprehensive. So one of the biggest ones is with forestry. So as I've previously mentioned, the ability for LiDAR to penetrate through the canopy makes it really good for reconstructing terrain and the forest structure. So this is really good for forest managers, for example, as well as researchers. So for forest managers, they can do inventory checks, things like productivity analysis. And for researchers as well, there's a lot of conservation applications, such as estimating the biomass. And from this, the carbon sink of the forest. For authorities to look at the fire loading of the forest. So that's a fire management application. And similarly, with agriculture, LiDAR is also really good for this because it's something which photogrammetry struggles a bit at, especially with dense crops. So it has similar use cases with forestry, so things like productivity improvements and analysis, estimates of yield, and you can also look at the different structural characteristics of the crops to look at the spread of disease, and also for looking at soil erosion. This is quite an important use case, which I think will get a lot of interest.
Yeah, we had a session with a university here from Germany. There's some vineyards in Germany, not that many as in California over on Liam, but I think also Liam, you mentioned a bit about the soil erosion that's being a very big topic by companies that are using your equipment.
Yeah, water, like everywhere in the world, is an extremely important natural resource in California. So one of the issues in forest management is making sure that your road networks are not committing too much sediment to the hydrological system. So there's a lot of benefits to being able to use that LiDAR, which can penetrate the forest canopy and the vegetation to model basically the terrain and then do erosion control analysis and monitoring. It's also important to do or becoming more used after areas are burned in wildfires, which we have had quite a serious wildfire season here, actually just this past year in 2020. And the idea there is to scan immediately after the fire, before the rains have come, to try to predict where maybe you'll have the potential for mass debris flows or hill slope failures to occur. So many uses for LiDAR that relate to just the ability to capture the terrain itself and then model things like hydrological processes and runoff on those elevation models derived from the LiDAR data or point cloud data itself.
Yeah, that's a cool technology. Also for corridor mapping, so like copper lines, I've seen LiDARs flying 1.5 years ago in China by a lot of Chinese power grid companies. using something like the LiDAR V back in these days. Now would be the V70. So they are essentially also doing vegetation monitoring with it, but also the sag measurement. It can be done by photogrammetry maybe these days, but I would say if you're doing it on a large scale and not on a pilot project type, the LiDAR will really pay off. We'll show you a bit of an example. Pipeline monitoring. So our colleague Mohammed has done pipeline monitoring with terrestrial laser scanners in several countries, Germany, Norway. I think that could also be very interesting for industrial assets to scan these kind of areas. And of course, we have the railway structure and highways, and we know that's being used there as well. We have seen interest from companies. We see companies using that one. In railways, you have the transmission lines. And then it goes over to construction architecture, topographic surveys as built in BIM. We have discussed this topic a little bit. So let us know what you think about this. Very excited to see where this technology is going. And then geological surveys and mining comes a bit similar to this soil erosion topic with landslide monitoring. Also change detection, volume measurements. That's something which are the use cases for LiDAR. Maybe very important also to mention that LiDAR is not an exclusive technology. We are comparing here LiDAR with photogrammetry, and in the next slide we're going to show you also a direct comparison, so which could get the impression of we are saying the one or the other is better or less good, but maybe even in the future it's going to be a symbiose of both technologies. I think we, as Liam has already said, we have cameras on LiDAR. The technology is getting smaller, so that means now you can also put the LiDAR and the camera together. It can all be in the back algorithms put together way better. So what is this overview here? Just to take away the, let's say, the burden of the high costs of an initial LiDAR procurement. We have the setup cost, so meaning the hardware, the software, also the training, all these kinds of stuff for the equipment, for the GNSS rover, for UAV photogrammetry, and for UAV LiDAR. UAV photogrammetry, Alex, I think that was a Phantom 4 RTK.
Yeah, that's right.
Yeah, and the UAV LiDAR?
Yeah, that was the LiDAR V70 with the M300 RTK.
Okay, yeah, so you see it's quite a mix also of technology. So in essence, we wanted to really take the real examples. And this is based on a 1 square kilometer survey area. How much time would it take to get the final results? Surveying this area with a GNSS rover, we had said that's around 3 days. UAV photogrammetry. You can of course tweak it if you put way more processing power, but we want to be realistic. You can use cloud processing, but of course then if you use cloud processing, you would need to have the setup really set very well. Also costs increase. Either you do it yourself training, or you are purchasing a very expensive photogrammetry purpose-made software setup. All these kind of things to take into account, and still it needs to be processed. So what we came up as a cost relationship is around 4 times. If you're surveying the whole year, you're surveying out of the whole year, doing a lot of surveys, that of course doesn't make sense for someone who's just doing 1 or 2 surveys a year. But then the LiDAR, if you are satisfied with the accuracy and the resolution, the LiDAR would be 4 times more efficient compared to a GNSS rover, and even 2 times more efficient from a economical cost perspective as the UAV photogrammetry solution. And here we have the accuracy of around 5 centimeter in the V, but also not to forget that this is the point clouds covered over the whole area, 330 million points, rather than to the GNSS rover where you have just 1,000 points. So let us know if that was helpful. If you would like to have this calculated for your project, we are able to reprocess that, maybe also for a different kind of equipment setup, for a different kind of area. and also then very important to the surveying days that you are having per year. And then we could let you know if that equipment is worth the investment. In addition to that, you will need to know the workflow setup of this whole equipment. A lot of technology is coming together. So the hardware setup, we have the drone, we have the sensor, we even have the base stations that we're going to utilize, maybe some subscriptions of custom network RTKs. Then we have the parameter settings that we need to think about for the LiDAR itself, depending on which LiDAR would be used. Then we're going to do the mission planning. I think also GreenValley will provide a very nice app for their hardware setups in the future. And then we have the data acquisition, the data processing. And for all of these kinds of things, these steps, we are going to provide you a workflow guide, as well as online trainings and on-site trainings would be possible. Also, if you say, I would like to test this equipment in a pilot test, that's something we can realize for you. And then a very important step of the workflow to get the final results for the end customers is the data classification and the analysis, final extraction of the information. Here's the thing that that Liam has already mentioned. So the software suits Lee Forestry or Lee Powerline, also Lee Terrain, which we would like to go a bit deeper in our next sessions. So I would like to hand over to James to provide us a bit of an outlook for what could come, and we hope that you will be in interaction with us. So thanks from my side so far.
Thanks, Tobias. So the outlook in terms of what we'll be looking at in the next webinars will be a detailed case scenario comparing laser scanning against photogrammetry and more traditional surveying methods. We'll be looking at the strength of LiDAR 360 toolsets for point cloud classification. And we will also have a use case focused with purpose-made GVI software solutions such as Lie Powerline or Lie Forestry. As Tobias quite rightly said, if you've got any questions, queries, anything you want to find out, any direction you want us to go in for the next webinars, please don't hesitate to get in touch. The details, our contact details will be left on the end of this video as well, and we'll pop them down in the description too. So on that, is there anything final that you would like to add, Tobias?
Oh, perfect. I hope you enjoyed this webinar. And would thank you from my side, everyone who has been here today, and looking forward to receive your feedback. And yeah, then for the next session, also thank GreenValley and Liam for being part of this one.
And Alex, anything from you? Anything you'd like to add?
That's everything from me. I'd just like to thank everyone for watching. I hope that was interesting for you and provided some useful information. And I hope you'll join us next time.
And last but definitely not least, Liam, anything from yourself, sir?
No, I just would really like to thank Tobias and Alex and you, James, and the whole Epotronic staff for putting together such a great analysis of how our technology compares to other technologies available and where it stands in the market today for customers and their options. And yeah, I look forward to the next webinar where you go dive a little deeper into the software side. Thank you very much for having me here today.
Don't forget to like and subscribe. And if there is anything further you need from us, get in touch. Thanks very much.